So our second thing we're going to look at here are when the top one was an x squared and the bottom one was an x and there wasn't a hole, then there could be an oblique asymptote. And when it has an oblique asymptote, it would also have a vertical asymptote at your non-permissible value. So the first thing you're going to do to check if there's any holes is you're going to try to factor it. This one on the top factors to be x plus 7, x minus 1 over x plus 2. Nothing simplifies. So this means that you are going to get a horizontal asymptote, a vertical asymptote at x equals negative 2. That's your non-permissible value. And then in order to find your oblique asymptote, what you're going to do is you're going to use synthetic division. So I have a 1, a 6, and a negative 7. I'm dividing by x plus 2, so I'll put a negative 2 out in front. Bring down the 1, multiply by negative 2, add, multiply by negative 2, add. And this means that your answer is x plus 4 remainder negative 15. Your oblique asymptote equation is y equals x plus 4, and you can forget about the remainder. If you want to read the exact reason why that all works, it's on page 108 there, but you're not going to be asked to provide, like, why is it that that becomes the asymptote. But as things get really, really big, it's going to get closer and closer to that line. Okay? And you only have oblique asymptotes when the power on the top is 1 more than the power on the bottom. So we have a degree of 2 on the top and the degree of 0 on the bottom. Okay? As far as looking at what happens, if we look, the pattern that we've been doing so far is looking at the highest degree. In this one, the highest degree is an x squared, and we have 1x squared on the top and 0x squareds on the bottom. This was our way to find out if it had any horizontal asymptotes. Can you see that this is not possible? So this graph will have no horizontal asymptotes. And in fact, when it has this as an impossibility, it will mean you have an oblique asymptote, especially if there's 1 degree above an x squared over an x. Because when you divide that, you'll get an equation with an x. We don't go into any equations that have parabolic asymptotes or cubic asymptotes or things like that, but they would be possible as well. Okay. For the second one, just to see if, it's the same one, right? So when we factor it, nothing cancels out. So we're going to have no holes in our graph. So this one, your vertical asymptotes are your non-permissible values, x equals negative 7 and x equals 1. If we look at the highest degrees, it's x squared. We have 1x squared on the bottom now and 0x squareds on the top. This is simplifiable. What's 0 over anything? It's equal to 0. That means we have a horizontal asymptote at y equals 0. And again, what we're going to do is we're going to be able to graph these. As far as graphing these, looking at our first one, you're going to start with all your asymptotes. So we have a vertical asymptote at our non-permissible value at x equals negative 2. And we have an oblique asymptote, which is y equals x plus 4. So you graph that line with your y-intercept at 4 and a slope of 1 and draw it with a dotted line as well. Y equals x plus 4. Then again, you can find out some other things, like you could find out, does this have any x-intercepts? Well, we factored it before, right? And we talked about the only place that you're going to have x-intercepts is when the top of your fraction is equal to 0. And you can see that that's going to happen at -7 and 1. So as far as graphing this goes, you're going to have an x-intercept there at 1 and an x-intercept 1, 2, 3, 4, 5, 6, we'll say here at -7. Now once you find a point in to the left and to the right of your horizontal asymptote, you can just draw it towards your asymptotes. And this one, oops, might be a little bit more like this, going towards this asymptote in the end. That's a really bad drawing. Bad. Okay. But again, once you have your points, you would draw a nice smooth curve through those and towards those asymptotes. That'll be what we'll look at as we do more of these. For this second graph over here, again, you would start with your asymptotes. This one has one at y equals 0, and the vertical asymptote at x equals 1. Plug in some values a little bit bigger than 1, a little bit smaller than 1. So if I plug in a value like 0, can you see that this is going to be 2 over -7? So as far as that goes on our graph, yes, this one had, yes, another asymptote at -7. Okay. Can you see on the top here that it's equal to 0 when x is equal to -2? So this is one of those graphs that goes through that asymptote. So we're going to find this section here. Now you'd have to check this with your graphing calculator, but I believe that's going to go look like that in that middle section going towards your asymptotes. And when x is bigger than 1, if you were to plug in 2, you could figure that out. And you'd get a point either up here or up or down there. Okay, so that would be something you would check. You could check it on your graphing calculator. I'm not sure, does it look like this? That's what I'm guessing, but I'd plug in values to check. If you check it with your graphing calculator, these lines might be flipped, but that's what I'm guessing they would be. Okay, 6 and 7 for this one. Okay.